Okay, so we continue on with our one-link planar robot. Sorry, let me get set up there. Yeah, and one of the things we did part A, where we kind of broke down, got this thing set up. In part B, it wants us to consider a robot such that L is 40 centimeters. I haven't changed my robot, but imagine this goes out to 40 centimeters. I suppose it begins rotating at pi over 8 radians, so it's already got an eighth of a turn, or sorry, an eighth of pi radians, so we know pi over 4 is 45 degrees, so it's somewhere in between there. And it takes 1 second to make a complete revolution. And what they want us to do is to let y of t denote the y component of robot t after rotation begins, determine all the parameters, and then sketch the sinusoid. So we're given, the parameters we're given. We're told that the length of the robot is 40 centimeters. We're told that it begins rotating at pi over 8. And so we talked about this being the amount that it's off to start with, and that's in an angle. So that is actually, they've already told us that our phi is pi over 8 radians. And then it takes 1 second to complete a revolution. So remember, the time to complete a complete revolution is t, which is our period, is 1 second. So yeah, if we remember the things we need to know to be able to get our sinusoid, remember it's going to basically follow this equation where y of t is a times sine omega t plus phi. That we've got 6 parameters that we're concerned with. One is the amplitude, one is the angular frequency, one is the phase angle, and then we have the frequency, the period, and the phase shift. And so there's 6 parameters, and this is, generally something that happens. Generally, you do get 3 of them. So we got 3 in this case, because really, I guess if you remember from the part before, we know that the amplitude, which is how much it varies, it's going to go from 0 up to L, back to 0, down to negative L, if we're looking at our picture, sorry. Yeah, so we know the value of our y is going to, it's going to be at 0, it's going to go up positive L, back to 0, down to negative L. So this is actually, the length of it actually ends up being our amplitude. So our solution, we've got 3 of our parameters immediately. We know that A is equal to L, so it's 40 centimeters. We have phi, which is how much are we off in rotation to start with. And so that's pi over 8 radians is how much our phase angle is off. And we know that t is it takes 1 second, our period takes 1 second to go all the way around. And now we have to remember some equations to get our other ones. Frequency is an easy one to get out of this. We know that frequency is 1 over t, because frequency is basically how many rotations do we get in per second. And so 1 over 1 second turns out to be exactly 1 hertz. I guess since these are final answers, I should be double underlining them. So 1 hertz. And I'm ignoring significant figures because these seem to be exactly 1 second. I assume if they measured it, it would be 1.00 or some other part there. And then, so that's 1, 2, well actually if we kind of number these, 1, 2, 3, 4, 5, 6. I've got 1, 3, and 5 were given. Maybe that's a better way to describe that here. Let's just say that, yeah. So I was basically given 1, 3, and 5 in this case. I won't always necessarily get those particular ones, but I'll usually get something. I figured out number 4 by using that. Remember this equation. F is 1 over t. I can get omega by using the equation that omega is equal to 2 pi times f. So it's essentially how many radians do I rotate per second. It's our angular frequency. And so that's 2 pi times 1 hertz. Two pi radians times 1 hertz. And so it's actually 2 pi. And remember the units of that are radians per second. Hertz is what, remember, hertz is 1 over seconds. That's another way to write that. I'm going to leave it that way so it's a little less confusing. But yeah, we're always remembering to have units. It's 1 radian per second. And then so the last one I need to find is the phase shift, which is parameter 6. And remember, phase shift from our previous stuff is phi over omega. And now I have both of those parameters. So it's pi over 8 radians divided by 2 pi radians per second. And so that is essentially 1/16 seconds. And so again, that's basically how many, based on time, I know I'm shifted pi over 8 radians. What amount of time would equate to do that? It's 1/16 of a second. So pi over 8 is 1/16 of a rotation. It takes me 1 second to get around in this case. So that's part A of or part 1, which is get the 6 parameters. And then for the sketch. So I'm going to stop and make a different video for the sketch.